Hello, my name is Lizeth, and I'm going to share my project with you, which aims to answer, could simple heuristic models explain how uncertainty is approached during exploration? So, one thing that's important to note is that exploration is an important part of learning. Learning is how we change our actions in order to interact with environments, optimizing our possibility of getting a reward while also avoiding some sort of punishment. And exploration is how we sample our environments, with our main drive being the possibility of a reward. One example is if you're picking between restaurants, you can either go to one that you already know or sample from a new one in hopes that it'll be better than the one that you know. But rewards are not certain. It's possible that this new restaurant, for example, is worse than the one that you know. So generally, during exploration, we are aiming to reduce uncertainty. But how does uncertainty affect decision making? Are we choosing the most uncertain option to reduce uncertainty, or are we avoiding uncertainty entirely and just remaining where we know the most? So in order to answer this question, in this paper, Human Exploration Strategically Balances Approaching and Avoiding Uncertainty, Michael Shadlin and Daphnia Shohami, which are experts in decision-making and memory, created this task where participants have access to 4 different tables with 2 card decks on each table, and they are picking different tables to pick cards from, so they're able to see if they're orange or if they're blue, and they are after some time of exploration, they have to pick which deck has the highest proportion of orange to blue for each table. And the authors proposed the following models to describe what the participants are doing. The first one is that they're picking tables at random. A slightly more complicated model is that they're picking tables based on their previous exposure. And then a slightly more complicated model is that they're reducing uncertainty by picking the table they know the least about. And finally, the most complicated model that they proposed is that the participants are maximizing their expected information gain, so picking the table that would give them the most information. And according to the results of this paper, it seems that participants are minimizing uncertainty, basically picking from the tables that they know the least about at a given moment. And so a little bit more about the paper in terms of how the experiment is set up and the demographics. There were 2 experimental sessions 3 and 4. 4 was paused prematurely because participants were talking within each other, so only experiment 3 is complete. So I used experiment 3 for my analysis. There were 62 participants in total, pretty evenly split among genders, with the average age being 29 years of age and the range of ages being between 20 to 38. And so something that I found interesting was if it was possible that simpler models or heuristics were explaining participants' exploration strategy. So I wanted to apply this model that we learned in class, which is the win-stay-lose shift. But because the experiment has no rewards, could it be that participants are picking the table where they get new information from, and avoiding tables where they are basically that just solidify their beliefs. Another model that I found interesting was temperature softmax. Could it be that after a certain point, the behavior of participants became more random? They were weighing less information into their responses. And finally, the limited workspace model, where we know that memory in humans is limited. Could it be that after keeping a certain number of items in our memories, instead of the normal reinforcement learning that we saw, could it be that after a certain number of tables explored, are participants presenting some sort of bias? And so the main model that I worked on was the win-stay-lose shift. So I simulated the data and then tried to recover the parameters. It seems that exploration and state probabilities was recovered, although I will say that the parameter recovery does not look great, which suggests to me that this model might not properly fit the data. And after modeling all of these models that I proposed, the best performing one was the random model. So I suspect that participants are not actually doing win-stay-lose shift, the softmax, or the limited workspace models, which actually I think just reinforces how well designed the experiment was. Participants don't seem to be forgetting. They don't seem to be making random choices as trials go on, which is good. Yeah. And so then I wondered, could it be that neural networks could provide greater insight into what variables are affecting decision making? Could it be that it was not something that I explored previously? So I wondered if there was some sort of table bias, or if previous choices were affecting the choices of participants. And it seems to be that the previous choice was the most important feature of my 3-layered neural network. But I also want to note that I'm not sure I trust this neural network, even though loss increases with training. The accuracy was worryingly high. And after playing around with the neural network, I don't think the experiment is set up in a way where I could just train this neural network to extract meaningful features. Maybe we would need more data. Maybe the experimental setup would need to be different. So in conclusion, participants do not seem to be using win-stay-lose shift or other simple heuristics in their exploration phase. It is still possible that win-stay could be a better heuristic than win-stay-lose shift. This has been proven to be the case for rock, paper, scissors experiments. And out of all of the models that I tested, the random performed the best. I will say I did not test out the model mentioned in the paper. And then, according to the neural network, the highest determinant of choice is the previous choice, but I don't think we can reach any meaningful conclusions yet. There would probably have to be some sort of experimental design changes in order for the neural network to work. My suspicion is that we are too limited in data to use a neural network. And the main conclusion I get from this work is, as the original paper suggested, uncertainty might be the most important factor determining the exploration strategy. And that would be it. Thank you for your attention.